Thank you for everyone for coming today. We're live streaming this event. We've had about 1,000 people sign up also for the live stream event. So between you and outside is quite an interest in today's talk. And I'd like to thank everyone for being here. Today we're going to talk about getting ready for the enterprise-grade era of quantum computing. When I started some 4.5 years ago, people said that quantum computing was still a long way off, 10, 15, 20 years. And it was largely uninvestable. I mean, most people don't realize is that if you're a venture fund, you have a window to return that money back to investors. And it's very unusual for that to be a 20-year window. Only 2 or 3 funds in the world have that kind of time frame. So when you go to a venture capitalist and say, I'd like to get your money, but I'm not going to see a return for 15 years, that's a really hard investment. It's even a hard investment sometimes for governments. I mean, elected officials don't stand usually for 20 years. So when I started, actually, the word is quantum was uninvestable. But we changed that narrative. We started by putting IonQ computers out on the various cloud providers. And people could actually start to use them. For just a couple of bucks, you could give it a try. Several years ago, people used to say to me all the time, quantum computers really exist? No, I didn't think they really existed. And I said, no, you can go out in AWS or Azure, and for $3 you can give it a try. And so we've started to change the narrative that quantum is actually real. But today we're going to look to change the narrative once again. So one of the not so fun aspects of being a public company is having more lawyers. So I'm not going to take up our valuable time by reading this slide aloud. However, we do advise you to please review our website with a similar cautionary notes, especially in advance of making an investment in IonQ. Okay, so, our goal here is to get to a place where quantum computers are powerful enough to show commercial value to our customer. And when we looked at this slide, we should have added to the end with as little error correction as possible. The more error correction that's needed, the more likelihood that quantum's promise is off into the future. So this statement is true on the screen. We've had a version of this now for several years, slightly modified over time, but I think we really should have added with as little error correction as possible. And one of the things you might have heard just recently is that we think we can get to AQ64 with error mitigation instead of error correction. And that's a big deal, and we'll talk about that today. So our technology is proven trapped ion technology. It has a few key differentiators, including all-to-all connectivity, naturally replicable qubits, long coherence times, high fidelity, and a modular and scalable architecture. We chose a qubit modality where the qubits themselves are naturally replicable and naturally quantum. And it gave us a huge advantage in that we started off with a very low error rate. And I think it's not controversial that everyone thinks that ion trap technology in the early days has the best error rates. And we've shown that, and also others who are doing ion trap technology. Over the past couple of years, and most notably this past year, we've seen great technical momentum for our ion trap technology. We've consistently tracked well against our public roadmap. This was basically the same slide that we did prior to the IPO. And we've exceeded our most recent AQ29 goal by 7 months. Assuming that we continue to meet our technical objectives, AQ64 systems are just around the corner. And we believe this is when enterprise-grade quantum computing and commercial advantage will be unlocked by our customers. And I'll talk to you about why that is the case. So our technology is not just driving momentum for IonQ, but also for our customers and partners. And just a huge thanks to our customers, partners, and investors who have been with us to help us get us to this day. We are on the cusp of enterprise-grade quantum computing, where quantum computing all really start to deliver game-changing value for customers. You know, we've been in this NISQ era where people are doing proof of concepts. And we're about to enter into a new realm where suddenly we can start to think about building applications which are powerful enough that they should be able to deliver value to our customer and put into a production environment. But you need a production quantum computer. So the NISQ era, we thought to be able to get to kind of commercial quantum advantage is that you would need to do lots of error correction. And in fact, actually, there's a fairly famous slide from BCG several years ago that talked about the 3 phases of quantum. So what's interesting today, and one of our first big announcements, is that we think even in the NISQ era, that we can get to AQ64 for customers. And we'll talk again about why that's so important. So I want to just talk a little about, you've heard our AQ numbers. The AQ numbers are based on benchmarks that the QEDC put together. It's a series of application benchmarks. And so I wanted to just talk about kind of how this scales. Of course, it scales exponentially. You've all heard that every time you add a good enough qubit, not just a physical qubit, one that has enough low error, that you double the computational power of the quantum computer. Quantum computing grows exponentially to numbers very quickly. We're going to be outside of your vocabulary. Actually, my guess is today we will talk about numbers that you've never heard about before. And going forward, that will be the case all the time. And in fact, actually, we'll get to a place where we need to come up with new names for some of the computational power of quantum computing. I'll suggest one today. So what this slide is trying to do is represent the growth of the computational space of a quantum computer. So if you were to consider AQ5, that it would be roughly, our analogy is the tip of a magic marker. And generally the circuits that you can run is about 25 entangling gates. So because after that, what happens is the error rate starts to come in and stop you from running larger circuits. So if you had AQ5, our analogy is about 10 millimeters. If you had AQ29, suddenly you would have the surface area of a basketball. And this is the system that we just released recently. And again, if you square the number, that's roughly the number of entangling gates that that you should be able to do with that system. So this is about 500 million squared millimeters in comparison to AQ5. And it also means you can look at those kinds of different states in this application. So at the same time, AQ64 is about, well, it's a little bit bigger than the United States. It's about 10 quintillion squared millimeters. Or in other words, is AQ64 is about 30 billion times larger than AQ29. The computational space of AQ64 is 2 to the 64. And that's roughly 18 quintillion. And to put that in perspective, Frontier's supercomputer at Oak Ridge National Laboratories calculates about 1.2 quintillion floating point operations per second. So now we're going to come to my first new word, is everyone in quantum is going to want to say, because I do it, is want to say quintillion is quantillion, but it's actually QUI. But we can save quantillion for some much larger AQ number in the future because we're about to run out of names for all these new very large systems. So don't say quantillion. It'll be exactly what you want to do because you're from quantum. It's quintillion. So we believe that AQ64 will be a game changer and bring quantum into the enterprise era, where quantum computers will bring real value to businesses. AQ64 unlocks a circuit depth of up to 4,000 entangling gates. So if you are now today playing with an AQ5 system, you're building circuits that have 25 entangling gates. So suddenly now you can start to build large applications using this machine. So we think that this is going to be a massive game changer. And so now, and you can look at these applications suddenly with, in parallel, in a fraction of a second, 18 quintillion different states in a single instruction. And just, we're now finally to the place, this is the place, to be honest, that when I joined, I dreamt of, that we would get to this place today, where we could suddenly produce applications that could take on the world's largest supercomputers for certain applications, of course, not everything. So today, companies and customers are doing proof of concepts. These tend to be small engagements where companies are just starting to learn about quantum. But now, today, given that this system is coming, it's time to move from proof of concepts to now to start to work on real applications. So my first call to action is for all of you to sit down and start thinking about what you're going to do with 4,000 entangling gates. What kinds of applications are you going to create? Because today is the day that you should get started. As an industry, we're looking for the next Bill Gates, who's going to create a basic for quantum. We're also looking for Dan Bricklin to create the quantum spreadsheet. So the opportunities here for companies, governments, is tremendous. We're just at the beginning. We're still waiting for that first killer application. The killer application has been waiting for the hardware to be fast enough and powerful enough, and it's now just about to be here. So my call to action to all of you is please be the next Bill Gates or Dan Bricklin and bring it to quantum. So new technologies come in waves. And those that see the waves in advance tend to be the ones who monetize it. And this has been shown over and over in various technology waves. And we think that it will happen in quantum as well. So like many technologies before, early adopters capture much of the value. So the question for you in the room is, are you going to be Blockbuster or are you going to be Netflix? One of those companies saw the internet come and the other one did something about it. So my challenge to you is quantum is coming. I'm telling you today, the machine will be here shortly and you need to be creating applications for it that actually be delivering real value for customers. We need to stop doing the proof of concepts and need to move on to applications. I haven't seen yet a circuit that requires 4,000 entangling gates in an application. So we need to start seeing those kinds of applications. So we've delivered on our roadmap so far. We believe that we are now within 2 years of AQ64 and commercial advantage. As I've said, now is the time to start building applications. When I worked with Ray Kurzweil, he's a famed futurist, and he's written books on the topic that predicts the future. What you might not have known is we use that as internal research to figure out when we should invest. And the time to invest is not when the technology arrives, but of course the time before. And so today is that time. And we're strongly urging that this new phase of commercial advantage. Because if we don't start to show that these machines produce real value, then venture capitalists and governments will not invest in them. So we're excited to be on this cusp and really in a new era for quantum. We do not talk about quantum supremacy or quantum advantage. The only thing that my customers care about is, can I build a better mousetrap and at a better price? And if I can, I'll make the sale, and IonQ will be successful. A good friend of our family was Arthur C. Clarke, and he's quoted with saying, if an elderly but distinguished scientist says that something is possible, he is most certainly right. But if he says that it's impossible, he is most probably wrong. What Arthur knew, that it was a fool's errand to try to prove what can't be done. And that's what I think quantum supremacy is. I don't know how I would prove that on a classical system you couldn't do something. But I don't think it matters. I think the only thing that matters is that I can show with a quantum application that I can deliver value that the customer doesn't have today. So we're not going to talk about quantum supremacy ever, hopefully. We think of it as purely as an academic term. So our roadmap is built on 3 pillars that make up the foundation of your quantum success. And each pillar is enabled by our hardware and services. First, you must empower quantum talent and drive workforce development. And you need universal cloud access. You need to make it easy for people to learn and use these systems. Second is you have to get production ready. That's what today's talk is all about. Building and testing production-ready applications ahead of these systems is very important. And we're putting you on notice today is you now have less than 2 years to be ready. And then third is you have to make sure that you have access to the most powerful systems, because you need to be able to run those applications in a production environment. And today as an industry, we're not there. And when I was at Amazon, if we were going to stand up a new service, we would calculate how long it took to run the service in wall clock time. And then we would look at the maximum load of users, and we would calculate the number of machines to meet a particular SLA. We need to do that now, starting in quantum. We need to get to a guaranteed SLA for the machines so that you can run production applications and make sure they run when you need them to run. Like if you're a logistics company and first thing in the morning at 5 a.m., you're busily doing 120,000 route optimizations, you need to make sure that the machines and the capacity will be there waiting for you, and there's no excuses why you can't be ready when your drivers show up at 6:30. So these are the 3 things that you need to do and to be able to get ready for this enterprise era of quantum. So we've got a robust portfolio of high-performance, current generation systems that are built for incubation, innovators, and application development. So, You've seen these systems before. You can see the AQ numbers, and you can see also how the computational states grow. So we started with our 11-qubit system, not to be confused about the number of physical qubits versus the ones which the error rate allows you to use fully. So an 11-qubit system, only 9 of them, the error rate only allows you to use 9. There's 11, but the errors are saying you can't use more than 9. And then the 25-qubit system, 32 qubits, but only 25 because the error rate isn't good enough to be able to use all 32. And so, and you can see here how the state grows. So Aria and Forte are our current generation systems for driving quantum education, exploration, and incubation. These are easily accessible via the cloud. So everyone in this room probably has one of the 3 cloud subscriptions in your organization. So you have easy access to these systems. They're not expensive to sit down and start to learn on. For a couple of bucks, you can run your first quantum application. So with Aria and Forte, you can start to create a flywheel of quantum innovation and incubation to drive your quantum proficiency and talent across your organization. So this is one of 3 major announcements today. Today, we're introducing Forte Enterprise. It's a rack-mounted system. It fits within your standard data center. You don't need to build a new building. It fits all the electrical and AC specifications that are found in standard data centers. This is an AQ35 system. So if you square that, says roughly you can do about 1,000 entangling gates with this system. This system is the stepping stone to the next system, which we'll talk about shortly. This system can explore 35 billion computational states. And as I said, circuit widths roughly of about 1,000 entangling gates. And so this will be delivered in this next 12 months to our first customers. In fact, actually, with Switzerland, they bought one of these systems and will be the first people to get this system put into their data center. And so we're very excited about this. The fact that it's a rack-mounted system. IonQ systems, you can walk into the room, you can have somebody walk by, it doesn't affect the system. We joke that all of our locations have freight lines next to us, and the ground rumbles. And that doesn't affect the systems. We're not actually sure that it'll work without a freight line. You might need a freight line to be able to get this to work. So we'll find that out. And Switzerland has 6 freight lines that go within 20 feet of where we're going to put this quantum computer. So these things are ruggedized, work in a standard data center. And this is, to me it still looks big, but this is 40% smaller than the previous generation. systems. And so in every generation, we're working on to get it smaller. And why is that? Well, because smaller is also a predictor of cost. And we all know that at some point, we're going to get to a point where you can't put more qubits onto a chip, and you'll have to go to a network and have multiple systems. But I need Moore's law to kick in. I need the cost of those systems to come down. Because if in the future you had 1,000 algorithmic qubits and you needed 8 systems that are all networked together, as much as I'd love to charge 8 times the current price, I think we need to be cheaper. Because we don't want quantum computers to be $500 million. We want them to be affordable. So we're working just as much on producing manufacturable small systems as we are in improving the gate fidelities. So we're very excited about this system, but it's the stepping stone to the next one. So Forte Enterprise is for public and private enterprises that want to have the most powerful quantum computer on premises. It's secure, easily deployable, highly available, and maintainable. It's intended to plug right into your existing data center and be compatible with all your existing IT and building infrastructure. It's amazing how many little details are required outside of quantum to be able to make it fit within a standard data center. Strange little things like LDAP, all sorts of things that you would have never think you'd have to think about. So this is the beginning of a mission-critical strategic asset that you start to house your valuable compute infrastructure. And of course, one of quantum computers' best friends is having a powerful classical computer nearby, so you can do hybrid compute. And this is available today. Like I mentioned, we've sold our first one of these systems and can be delivered to you in 2024. These systems will be coming out of our Seattle factory. And so this will be the first system that's not being built bespoke, but is now being built in a Henry Ford-style production line, where we're building multiple systems at the same time. We're working on things like making sure that all the components are easily accessible, and that if a power supply goes down, you can easily slide it in and slide it out so that your downtime is as small as humanly possible. So this is a game changer for IonQ. But now I'd like to introduce IonQ Tempo, our next generation system with AQ64. An unimaginable 18 quintillion different computational space that you can use with this system. This one, substantially smaller again, fitting in roughly 3 racks. So a huge size reduction from the previous generation. Where this one is intended to be in a production environment, you probably buy several of these to be able to hit your SLA for your particular application if you're putting it into production. This is a monster of a machine. This is the machine, when I joined IonQ, this is the machine that I joined for, to be able to show real value to customers with a quantum computer that's actually powerful enough to deliver that. And that's this machine. And also in Switzerland, they bought 2 generations of systems. So they bought a Forte Enterprise. And today you can see the second system, which is an AQ64 system. And this one roughly is about 34 billion times more powerful than the previous generation of Forte Enterprise. And I'll say a little cheekily that if you don't have one of these, then you're probably falling behind. So we encourage people to be able to get access to this. This is for IonQ, the next system that will come out of Seattle. and will be built in our factory as well. We will look to start producing many of these to be able to hit customer demand. And as I mentioned, about half the company now is working on manufacturability of quantum computing and reducing the cost. And so it's a busy time. In this quarter, we will actually cut the ribbon to be able to open the factory in Seattle. And we've already hired, I think, roughly 50 people to start there, and we will grow that workforce in Seattle quickly. I'll mention, too, that one of the things that we're actively working on is quantum networking. So you saw in the Forte Enterprise, where it showed the little beams of light, it won't actually look like that. It's actually going to be a fiber optic cable instead. And so we're working on that as well, and you'll hear those announcements over the next 18 months or so. This is the first machine that with our customers, we are working today to create applications that can take advantage of these kinds of circuit widths. So what we've seen so far is that with a smaller quantum computer, we can often beat, especially in things like machine learning, the best classical algorithms. But what's interesting is the applications seem to scale very well with the number of qubits. Like for instance, when we were doing object detection, we noticed that just adding qubits to the problem actually increased the success rate of the object detection. And so we think with this, and if you think about this, there's a video too that will show you, it's up on our website, that talks actually to how does the quantum computer do object detection. We encourage you to watch that. But in these early machines, it could only load low-resolution images into the quantum computer. But with these machines, suddenly you can load, very high-res images, if not entire video sequences, into the quantum computer to do object detection all in parallel. So these little applications that we started with, where we started working on finding the general algorithm, seem to be scaling very well with the power of the quantum computer. And Jungsang will talk more coming up about that. So we have machines that are designed to support you at every stage of your quantum journey. If you have not tried our systems yet, please stop by our booth to get more information. And with that, and so you've heard two announcements. There's a third one still to come, major announcements. So you've heard the Forte Enterprise and Tempo. And at the end of the presentation, we'll give you the third major announcement of the day. But till then, please welcome Dr. Jungsang Kim, who will walk us through the work we're doing with our partners.
All right, thank you, Peter. I am very happy to be here. My name is Jungsang Kim. I'm one of the co-founders of IonQ, and we definitely have been looking for the technology progress to get to a point where we can actually deliver a meaningful value. So as Peter mentioned, we have been building better machines, but better machines can be a nice big box if you don't know how to use it. I think it's really important for us to figure out what to use it for to create the commercial value to the users. So this is our technology roadmap that was shown earlier, but this time with a little bit of focus on what we think the use cases may be. And we have outlined that quantum machine learning will be one of the first use cases. And we believe that the enterprise-grade quantum computing, which is where enterprises can actually start to see some real value, can really happen in the next 2 years as we build powerful enough quantum computers that can actually do things that classical computers will have a challenge of doing. But in order to actually make that happen, we actually have to start thinking about developing and creating a product scale applications today. So with enterprise applications, when they are ready, we can actually start to provide commercial value. And IonQ plans to deliver the hardware, quantum computer hardware, that's capable of providing those capabilities with AQ64 and beyond. And it's, as Peter indicated, we expect that to be in 2025 and beyond. So some of the early indicators of what quantum applications can do, we are finding out that quantum machine learning models can be a lot more efficient in capturing structure in the data, especially when there's a lot of correlation in the data. Those are places where we believe quantum computers can be advantageous. So we currently, as Peter's call for action, we need to focus on developing applications that actually have commercial value. And those applications and opportunities come from everywhere. They don't necessarily come from quantum computing companies, but they come from enterprises that are actually operating their own business. I am sure all of you are thinking about very challenging opportunities or where a new technology solution can actually enable new opportunities. In order to actually get build up for that future, the future of an early adopter and front runners who can capture the value of quantum computing time opportunity, we need to start with making sure that you have talent that's empowered to find these early solutions. So at IonQ, we have quantum experts who is more than ready to work with those domain experts in your companies and your enterprises or your research organizations who can develop new ideas for various real-world problems that we can tackle with the power of quantum. And actually, we can actually create some proof of principles to actually train your workforce and eventually create a roadmap for those applications to impact your business. We are actually in that, once you have the talent, we are actually more than ready to actually work with you to create production-ready applications today. With the anticipation that in a few years, we will have quantum computers that will be able to do things that classical computers will have a hard time competing with. So it is very important for those front runners to start the effort to get ready for quantum-enabled products today. And we can help. We can partner, and we can push that frontiers forward. In this phase of preparation for production, we identify innovative quantum solutions to commercially viable problems and challenges that you have, use cases that you have. And we can pilot applications and develop a maturing platform so that we'll be ready to deploy at scale when the high-performance quantum computers are available. And of course, as the product-scale quantum applications develop in the next few years, we are ramping up our production capabilities so that we can actually deploy this at scale when you're ready. So I'm going to give you a couple of examples of things that we have been working on in the last few years. Actually, one of the examples is advanced quantum machine learning. You know, machine learning and AI is applied everywhere today. Right? There isn't a field or an area or industry that you can think of where people are not thinking about deploying AI or machine learning. Things were not like that 10 years ago, but those who actually have led the charge certainly experience a huge advantage today. Now, the potential for quantum is just as large, meaning there will come a time where I'm confident there will come a time where quantum technologies will be applied to a very large number of industries and use cases that we are not thinking about today. Now, here we show an example of work we have done with our partner, Hyundai Motor Company, for the last few years. And here we developed a novel image recognition techniques. And of course, the use case we're thinking about is shown in this little video. As you drive, there will be road signs and things like that that we recognize. But if you are thinking about a more advanced self-driving cars, there has to be machines who will have to recognize that. And those are challenging example problems. And we actually have developed a novel quantum algorithms for identifying this. Now, the technical details of this, as Peter indicated, we've made an instructive video, so you can actually look at it on our website. But these highlight that quantum can be very powerful because we can actually have very expressive models leading to much more efficient quantum machine learning. Now, a second example is a logistics problem. Here, we partner with our customer Airbus to think about cargo loading, where you have a bunch of packages that have to go into a bunch of bins in an airplane, but you also have to make sure that you don't overload the aircraft or imbalance it so that the aircraft tips. So these are types of lots of possibilities, but also we have a lot of constraints. Those constrained optimization problems turn out to be a very challenging problem in logistics. We have developed a quantum machine learning, quantum optimization algorithm to actually tackle this problem that combines both machine learning and optimization subroutines. These types of solutions, we're actually using it as a template to continue to develop a production scale platform over which these things can be.
With IonQ, we are studying one of our applications, aircraft loading. It's a constrained combinatorial optimization problem. It's well suited for variational optimization on a quantum computer. It's definitely a challenging use case, but when we reach quantum advantage, it would have an important impact. It would be an important business application to drive efficiencies and to reduce the environmental impact of our products. And ion-based technologies like IonQ's offers promising opportunities because it's well suited for variational optimization problems. And IonQ provided us accessibility so that we were able to test our use case on real hardware and see real results.
That was from our partner at Airbus, highlighting the efficiency of our collaboration. Now, I've given you two very short examples of the use cases, but there is numerous more. But I think one of the real opportunities is how do we actually take these progress that we have made and start to drive an economic driver. The combination of the talent training I mentioned about, the quantum solution development effort that we should all embark upon, and access to high-performance quantum computers available from IonQ, they provide a fruitful opportunity for developing commercially viable applications. And there are more coordinated efforts to try to harness that to actually create an economic driving engine. And Quantum Basel is a great example of such a quantum innovation hub. And here IonQ is partnering with Quantum Basel to create a vital ecosystem for quantum technology innovation to drive economic growth by focusing on enabling local enterprises to develop innovative solutions for real-world problems. Here's the CEO of Quantum Basel, Demir Bogdan, describing our collaboration.
We are very looking forward to welcome IonQ as our addition to our global partnership system for quantum computing here at Uptown Basel. IonQ's technology, IonQ's R&D will attract more business partners to invest into quantum computing, will attract more startups to join our ecosystem, and furthermore will attract future workforce to collaborate with ours. IonQ's technology, alongside our other partners, is especially good, be it for use cases in the field of logistics, industrial production, or life science, chemistry, material science. This is something which differentiates quantum computing from traditional computing.
All right, so besides all of the other, a couple of examples I've given you, there are many, many other examples of real-world use cases that IonQ is actually collaborating with our partners. And there are numerous more opportunities that we have yet to embark upon. So the call for action is if you are an enterprise who wants to become a front runner, or if you want to, if you're a local or federal government who's interested in stimulating quantum economy enabled and empowered by advances in quantum computers, this is a time to really think about the economic impact of different applications you can develop. Now, we didn't have a lot of time to get into the technical details of our roadmap. We are planning on a webinar next month where we dive into the details of that. So if you're interested in kind of our technology roadmap, please join us in the next, on October 26th. So with that, I'd like to see if I can call Peter back onto the stage to wrap up our conversation.
Thanks, Jungsang. So as we've looked at here today, We have the systems to be able to start to build what at Amazon we would call a flywheel, for you to be able to have that flywheel and it starts to spin and generate new value for you and your customers. We've laid out a path from today to where we think that you will be able to use one of our machines and be able to deliver value, real customer value. So, become the quantum frontrunner going forward, using your local workforce, your startups, your investments, and IonQ hardware. And let's bring quantum to kind of the promised land that we've all dreamed about. And our call to action, of course, is to get started. The last thing that I'd like to talk about is our last announcement. And the last major announcement. I'm delighted to announce that IonQ has signed an agreement with the Air Force Research Lab, AFRL, to continue our engagement and offer IonQ quantum computing and quantum networking to advance AFRL's groundbreaking work. This is a $25.5 million agreement that reflects the strength of our commitment to AFRL's critical missions. I want to thank Dr. Michael Haydock and the entire team at AFRL for the confidence in IonQ to deliver on our commitments. We're excited about our joint advancements in quantum computing and what our future systems will enable for AFRL in the world. This announcement is significant in a different way, in that it shows that quantum is actually a business. Because very quickly, you're seeing IonQ's bookings growth and revenue growth continue in a way that I don't think the quantum industry has seen before. And so IonQ was a front runner, obviously, being the first ones to go public and also to raise some roughly $800 million in the process. But now we're turning it into a real business. So this year, we've blown out our numbers in terms of what we told the street, and we continue to do so, and the year's not over yet. So in addition to not only having great hardware, but we actually have a great business as well. And so that's also exciting, not just for IonQ, but we're showing investors that it really is the case that quantum can be invested in and companies can make it a business. And so we hope that while we're doing well, that the rest of the industry follows suit and investors can have confidence, not just in us, but obviously in all the other quantum startups that are out there. And that we're kind of, if you will, we're raising the tide for all boats, if you will. So we're very excited. And just to final two new systems today and $25.5 million in new revenue, new bookings this quarter. So it's been an exciting time. We look forward to this journey with you over the next months and year, and we look forward to working with all of you. Thank you so much.